is to the first objective, or basically the first objective or the first purpose of data design is to simplify the relation, right? So because we have designed the schema during the last 2 or 3 phases of database design, now because we are going to use the data, so it is important to place the data values in a manner which can be accessed efficiently, which can be modified efficiently without creating the redundant and null values. Because uh, based on the observation from the past or previous researcher or database designers, it has been observed that because of the redundant data or redundant data value in the database, uh, there are a lot of problems we face. Like in the previous lecture, we have pointed out that maybe because of these redundant value, redundant means we are having multiple copies of the same data, and because we are having multiple copies of a data, we need to perform any operation, like any DML operation twice, right? So maybe on behalf of us, DBM system is performing this modification, then also it is not advised to keep the redundant copies of a data, right? So the single objective or single purpose of data design phase or data design step is to minimize or to control or to reduce these redundant values, and somehow if we have null values in our database, then we can basically take care of null values also, right? So to basically take care of these values, how to minimize these redundant or null values in the database, the step, basically there are 2 or 3 steps defined. The first step is to, in this direction, the first step is to identify the FDs, right? So you need to identify all the possible functional dependencies in this database, or maybe in that particular table, and based on this FD, the second step is to determine what are the possible, you can say prime attributes, or maybe the important attributes based on which we will be actually simplifying, or we will be splitting this database relation, right? And this splitting or this normalization or this simplification will basically make your data base or maybe your database table in a way that we will not have these redundant values, these redundant instances of a value, right? So there are 3 steps involved. So first step we have discussed in the previous lecture, where we have discussed what is the purpose of deriving FDs and how you can derive the FDs. So in the first instance, you can derive the FD, and then second instance, you can uh, generate more FDs by using the inference rule, right? So we have primarily perform step 1A, 1B. So because in the first step, our objective is to derive the FDs, functional dependencies, on a database relation, on a database table. So suppose we have multiple database tables in a database, so you should be going one by one. So you can be taking one database table at one time and derive all the FDs. In the second instance, you will identify possible FDs in the second relation or second database table, something like that, right? So likewise, you need to perform this identification of FDs for each and every database table. That's the first step. And while performing this FD identification, naturally based on the data values, based on the keys which we have defined, after that you can identify, or you can see what is there any additional FD possible. So for that, you can be using these inference rules, right? Inference rules are basically used to identify some other possible FDs in a particular database table. So after doing this, the second step is to, because now we have FD, set of FD. So we will not talk about database table, database relation. Now we will be discussing, or we will be trying to find out basically what are the attributes of a relation which are more important, which I say a prime attribute, right? So prime attribute term is a very important in the theory of data design, because prime attribute will be used to determine all the attributes. So suppose there is a database table given which has 5 or 6 attributes. Out of these 5 or 6 attributes in a database table, some will be playing as a important role to derive the values, right? Like, so because if we take some examples from the real life or real world database systems, for a user of the database system, we used to give one or two options on the GUI, right? So suppose you want to access the detail about your accounts, or if you want to access the list of trains between two pair of stations, you need to provide only these station names or these source destination station names and date of journey. So based on that only, it will retrieve all the possible trains likewise. So so for a user, or for any naive user, or for any user, we used to provide uh, these attribute names, these candidate attributes name, these prime attributes names on the GUI, right? So it is basically important that whenever we are identifying FDs, based on these FD, you have to identify the prime attributes also, because it is the prime attribute which will help you to retrieve the other values in the database, other attributes in the database table, right? So that's the purpose of candidate key. So because in the last lecture we have discussed this fact that candidate key is having different purpose, right? It is not a key equivalent to primary key. So because the purpose of primary key is to identify each and every tuple or each and every row uniquely. So that's the purpose of primary key, and it is already done. So we cannot say that now primary key is still being used within the candidate key. So yes, in few cases, whenever we are deriving a candidate key, primary key attribute will be part of it. Sometimes it happens, but it is not a rule, it is not a necessary condition that whenever we are designing a candidate key, the primary key should be part of it, right? So we will have different attributes for primary key, and we can have different attributes for candidate key, right? So these two, candidate key and primary key, are having different purpose, and both are different, right? So the purpose of candidate key is to provide basically the access on the data value. So like if there is in the database table, if there is a tuple given and you want to access each and every value in the tuple, it is the candidate key which will help you to retrieve each and every data value in that tuple, right? But you cannot access each and every value, like you cannot access date of birth, you cannot access email ID separately by using primary key, but by using candidate key, you can access this, right? So today we are going to discuss these two concepts, right? And along with it, basically there are a few other concepts. So let me share the class notes of today's lecture. So I will begin by the concept of called closure, right? So closure is basically having this one very simple definition, right? And based on this closure concept only, we can identify the candidate key and super key, right? So basically we have taken these basic concepts, why functional dependency and data design theory is important. Now if particular database relation is having this kind of FDs, so let's have these three FDs. SSN determines first name, second FD is P number, determines P name, project name and project location, SSN, P number and R. So we are taking any these FDs are coming from any random relation. It is nothing to do with our company database, right? So because whenever we say we have set of FD, so these set of FDs should be coming from a single database table. You cannot have set of FDs for whole database, right? It is very clear. You should be having this clarity that whenever we have set of FD, whenever we are deriving set of FD, it should be coming from a database relation, from a database table. We cannot have all the set of FDs for database, right? So because database design theory says you should be dealing with a database relation at a time, right? So based on this FD, this concept of closures there, you need to identify, you need to see out of these FD, if you use each determinant. So this left hand side attribute is considered as a determinant. So these attributes which are placed in the left hand side of a FD are called determinant, right? So you need to see by using this determinant SSN, what are the attributes we will be able to access, what are the different attributes which we can access if we have the value for SSN attribute. we can access first name. That's it. So is it possible to access others also? You need to see it. So if we identify what are the possible attribute which SSN attribute can access. So if you have a data value for SSN attribute, what are the different attributes you can access? So based on the FDs, you can easily identify. So by using SSN, if you can say, you can or you may able to access only first name, right? Because it is given or it is identified on the FD. Similarly, if you have the values of project number, P number, we can access the project name and project location, right? So these are the two possible attributes which we can access by using the value of project number. Next thing is SSN and number. So if these values for SSN and P number is given to you, what are the different attributes you can access? You can access R's, right? So if you see, but because in the last case which says SSN and P number, so you have two values. And if you see carefully, if you consider the previous FDs also, if you have given SSN and P number value, then you can access R's. Then you can access R's, first name, P location, each and everything basically, right? Because here in this case we are having two attributes, and in these two attributes, this SSN is able to access the first name also because of first FD, and because of second FD. If you have P number, you can access P name, P location. So eventually, if you see this SSN and P number will be able to access each and every attributes of the relation, right? So this is something you need to understand that too, because now we are going to have this idea that what is the minimum set, what is the attribute set we should have whenever we want to access the each and every attribute, each and every value uniquely. So that is the objective for which we are discussing the concept of closure. So like you can say here, you can see here it is represented as theory, like if you want to represent that which of the attributes set which SSN is able to derive. So it is represented as SSN and then plus this plus symbol indicates that we are trying to identify what are the additional attributes we want to or we will be able to accessing by having this SSN value with us, right? So if you have SSN value, so you will see all the FDs. So SSN is able to derive SSN and E name. That's simple and obvious because of first FD. Similarly, P number is able to derive P number, including self P number, P name, and P location because of second FD. And if you go for third FD, third determinant set, which is SSN and P number, it will be able to retrieve all. It will be able to derive all the attributes of a relation, right? So this is how we will be able to determine the closure, because closure basically gives you the idea that by using this determinant, so it is very important. It is very important whenever we say determinant, it means it is the left hand side attribute of a FD. So because of or by using the values of these determinant, I will be able to derive these attributes of a relation. So it is very important to understand that which closure. So these four are the closure sets. So for this given set of FD, we have these three set of closures, right? And out of these three, this last closure set, which is SSN and P number, SSN and P number will be able to derive all these FDs, all these database attributes, right? So it is very important to have this kind of idea that how to identify and which two attributes or which are three attributes are important or will be able to derive the remaining attributes, right? Because based on this theory only, we will be able to have this this concept of candidate key, right? So now I'm going to introduce you the term called candidate key. So candidate key is basically, we have just discussed, it is a set of attribute. It is a set of determinant attribute actually, right? So it is very important to mention that candidate key or maybe closure set will have the attributes which are falling in the determinant side. So it is the set of attributes. It is the attribute which is in the left side LHS of the FDs, right? So we cannot take any attribute under the closure set or under the candidate key which is falling in the right side, right? So now basically candidate key, so there is no specific definition of candidate key. So you can take this definition that candidate key is a set of attributes which will be able to derive all the attributes in a relation, right? So maybe informally you can understand this, that from the derived set of FD, so we have derived all the FDs of a database relation. The closer set, let me place it, a closer set that has capacity to derive all the attributes of a relation. So that's what I'm saying. So like in the previous case, we have derived 3 closer sets because we have 3 FDs, right? Eventually we have 3 FDs and we are having these 3 closer sets. So out of these 3 closer sets, we need to identify, or we need to have this at least one FD or one closer set through which you can determine all the attributes. And we refer, or we called this closer set, or this attribute set as a candidate key for the database or for the data relation. Right now, what is the question, like what is the use of candidate key? So we have discussed it is to determine it is used to determine each data value in a tuple, right? So this term is important, each data value, because this is the purpose we are looking for, right? Because till now we have this concept of primary key and we have other keys also, but before this candidate key, no concept or no notion or nothing is basically helping you to derive each and every data value. I'm saying, not tuple. Tuples we can identify, or tuples we can spot by, retrieve by having kind of primary key only, right? But candidate key will help you to identify each data value in a tuple, right? Now, basically how these candidate keys will be used. So we have said that candidate keys are something which can be plugged into GUI. So whenever we are designing a software system or any system which is used by some kind of users, these candidate keys will be directly plugged into GUI, right? So through these GUI, user will be supplying some values on these candidate key. So it is sufficient, right? It is sufficient to access any value in the database. So if we plug these attributes, these candidate key attributes into the GUI or user interfaces, user is able to access each and every remaining value of the database relation. That's what the purpose. That's why we have worked upon the closer sets, right? So now, so basically these candidate key will be plugged in the GUI. Now, basically, if you see, because we can have multiple closer set on a database set or FD set, we can have multiple candidate keys as well, right? So it is not necessary that for a database relation or for database table, you can have only one candidate key. You can have only one closer set which will be able to derive all the remaining attributes. There are various cases, there are various instances that in a database relation, we can have multiple candidate keys, multiple closer sets, right? Which will be able to derive all the remaining attributes. So, so you should be working upon this this perception that whenever we are deriving the candidate key, whenever we are deriving the candidate set or maybe closer set, you should be working upon exhaustively, and you should be deriving all the possible candidate keys, right? It is important. So you can say that deriving the candidate keys or deriving the closer set is a exhaustive process, right? So if a FD set or functional dependency set is given to you, you need to identify all the possible candidate keys, right? You should be looking upon the possible combination of determinant attributes and try to derive all the possible candidate key, right? That's one bit. So so let's take at least one or two examples. So you can see the first instance. It says suppose there is schema is having 4 attributes S, T, U, V, and these are the FDs given. S determines T, T determines U, U determines V, and V determines S. So what do you think? What are the possible candidate keys? So can you respond to this question? So for a given set of FDs of a relation, can you list down the possible candidate keys for this one? So go ahead. So let's take a few seconds and try to answer this question. So you need to see the shared question and you need to post the possible candidate keys for the given relation. Yeah, keep posting your replies. So for this FD, you can have candidate keys, different candidate keys. So let me know. So let's take 5 more seconds to reply to the question. I'm waiting for your replies. Keep posting. Yes. So basically, because if you can see carefully, if you have S with U, so you can identify primarily by this FD you can have ST, by this FD you can TU, by this SD. So likewise, you can see. So basically, first 4 closure set will give only 2 attributes. Now, if you identify it carefully by having S attribute also, so you can say this S plus will give you. Let me place properly. This F will basically give you. So it will give you S and T. And now, if you see, if you have P, you can identify U, something like that. If you have U, you can have V with you. Now with V, you can have S again. So it is basically kind of circular or a transitive rule, right? So similarly, if you have T, then you can say I can have uh, this because of this FD. You can claim that now with T with us, now we can able to identify U. Then with U we can have V, then S, something like that. So likewise, I can claim that for this FD S, T, U, V, all these 4 are candidate keys, right? So at any moment, if you want to use this candidate key, the candidate key of this relation in the GUI, if you want to give it to the user, you can have these 4 options. You can provide this S to the user, or you can provide T to the user, or you can provide U to the user, or V. So you have 4 alternatives, or any out. So you can use any of it, and you can provide this to user that you need to provide. You can ask user to provide the values for any of these particular attributes if you want to access all the remaining attributes. So basically, the concept is like, if you adding this S into the GUI, then you can claim that by having S, I will be able to identify these attributes, right? So because now we are taking S and adding this S into the GUI, or maybe in any front-end interfaces, all remaining attributes will be able to determine by having this S value. So you can see, if I am considering S to be added into the GUI, all the remaining attributes will be become non-determinate. Actually, it is not non-prime. So any attributes or any candidate key which you are taking will define or will indicate that these attributes will be becoming a prime attribute or important attribute. Other will be becoming a non-prime. Maybe in the second instance, or maybe for the second student, remaining attributes, you can take any of the remaining. So like in this case, we have these 4 as a part of, or maybe the candidate keys. So you can, if you take any of these, any of attribute from this set, you can claim that remaining will be. So like in the second student, or maybe second student take T as a prime attribute, or T as a candidate key. So for that student, S, U, and V will become the non-prime or non-determinant, right? So likewise, you can identify the possible candidate keys, and you can identify that out of these candidate keys, which candidate key I will be taking for my development, or my system design, or my data design. So let's take next question. So there is this database relation given with 4 attributes A, B, C, D, and FDs are like B determines D, and D determines B, and A, B determines C. So now you have to identify the candidate keys for that. So let's take few seconds and try to respond to it. So let's reply to this question. What is the possible candidate key for this? So anyone can respond. So what is the possible candidate key? So if you have B, you can claim that I have B, and with the B I can determine D. And if you have D, so you need to focus on the attributes, left side LHS attributes placed on the left side of the FD. So by having B, you can determine D. By having D, you can determine B. Now by having A, B, you can determine C. So which is the most minimal or most set of attributes? You can claim that. Yes. So the first obvious choice is A, B. So by using B, or by using this determinant A, B, you can claim that I can access. Yeah, let me place it properly. So yeah, by using AB, I will be able to determine A, B, just a minute, A, B, C. Now that's obvious. Now just because it is mentioned in the previous FDs also, if you have B at any point of time, because it is mentioned that B is now also accessible, right? So by using A, B plus, or by using AB attribute, you can, or you may be able to access all the attributes of this relation, right? And D is accessible because of this first FD, right? So that could be the first candidate keys. Now you can have, now you can have other FDs also. So let me know. So you cannot say AD. So AD cannot be. It is not AD. AD is not a vital option, because for AD, you need to cannot be, right? So because for AD, to make AD as a candidate key, you need to do what? You need to break or lose B. Like we have these four determinants. We have determinants as B, D, A, B, you can say like this, A, B. These are the determinant set. Determinant set, right? Determinant set is having these four attributes. So you can take anyone from this set, B, B, A, B, and try to derive the possible. If you are not able to derive, or if any of these determinant is not able to derive all the attributes, then only you can be combining more than one. So you can combine B with D and see if BD is able to determine all, or you can combine D with AB, or you can combine A with B. So B is already there in the AB. So you can have two options, BD, right? So you can have BD. So you will be looking at the options, like let me write here. So first option we can use BD, then we can have ABD. So you can experiment for these two options, because AB is already with it. So you can see by using BD, you will be able to access only, I think, BD itself, right? But by having this option ABD, you can claim that ABD is also able to access all the attributes. So ABD is also a viable option. So you can use this. So let me mark this also as a candidate key or closure set, which will be able to access all the remaining attributes, right? So let me say like this. Sorry. Yes. So by using ABD, you can claim that I'm able to access all the remaining attributes. But AD cannot be, right? So let me place it here. Yes. Right. So you need to see for this particular database schema, for this second one, we have these two AB, and ABD as a candidate key, right? Because by using these two, you can access, or you can basically derive all the remaining attributes, right? I hope it is clear to you. Now you can see out of these two, A, B, and ABD, though we are able to access this whole relation, whole attribute, but it is a wise idea, it is suggested idea to have. So now you have two candidate keys, AB and ABD. So if you compare both, we are able to access this whole relation by using only AB, right? You can see easily that by using AB also you can able to access the remaining attributes, and by using ABD. So the best approach is to go for the minimal set of attributes. So I will be going for the FD. So using AB as a candidate key is the best idea, because it is having the smallest, or you can say optimal, or you can say the minimal, right? So there are two terms, optimal and minimal. So optimal means you need to have at least lesser number of attributes, or you can say the best set of attributes which may able to access the remaining attributes of the database relation. So out of these two, going for AB is the best approach, right? So out of these two, going for AB is the suitable approach, and going for ABD is also okay, right? Because second student, other student may wants to have this ABD option, right? And for this database relation, both are candidate key, right? That's what we have derived. Now, if you see, without having D also, you may able to access the same relation. So I can claim that this ABD is a super key, right? So whenever we have set of candidate keys, and we realize that by removing an attribute from the candidate key, then also we will be able to derive the relation. Then we can claim that this key is now a super key. It is candidate key naturally, but now because by adding some attribute, it is also able to derive the attribute, or maybe by removing it, we still want to access, or we can access the database attributes. Then we can claim that attribute is a candidate key. So for this database relation, AB and ABD both are the candidate key. That's for sure. And let me type candidate key are ABD and AB and ABD. But just because ABD is having this extra attribute D, which is important. But if you remove that D from the candidate key, then also it is able to access the remaining attributes. So I can say, or I say this ABD candidate key as a super key, right? So I hope you can correlate this concept of super key, right? Because super key is nothing but it is a superset of candidate key. So superset means if you have a candidate key and want to add an additional attribute on the candidate key, then you are deriving a new key which is called super key. So it is basically candidate key plus, or maybe a candidate key with an additional attribute, right? So objective of both will be to derive the remaining attributes or deriving the value. So let's have some points on it. So basically, how super key? So super key is a superset of candidate key. So you can write in a brief manner like candidate key with additional attribute. That's simple definition of it, right? So now you can you can use the super key whenever you want, wherever we are using candidate keys also, right? So super key, the use of super key is same as the candidate key. So like in the previous discussion, we have taken that candidate key can be used to derive the values. So wherever we are using candidate key, there you can use super keys also, right? It is up to your approach. So if you want to provide these additional data attributes along with the candidate key, then we can say we are using the super key approach, right? But it is important. So whenever we are building a GUI as an interface for the user, whenever we are adding these candidate key into that in those GUIs or interfaces, you need to add these additional attributes as an option. That's what the important part is. So whenever we are adding these super keys or these candidate keys in the GUI, so this additional attribute, like in this case, D is additional attribute. So just because of adding D in the candidate key, it will become super key. So you need to add this D as an optional value. So I hope right. So it is same as the candidate keys also. Like in the previous statement, we have made that for a functional dependency set, we could have multiple candidate keys. Similarly, we could have multiple super keys also, right? So that's it for today's lecture. So we have touched upon this basic concept of okay. So Sanjay posted a reply like ADC. So ADC, we cannot have ADC, right? That's for sure. The reason is that in a candidate key or in a candidate set or a closure set, we can take attribute from the determinant attributes. So out of these FD, B determinant C, and out of these FD, C is not a determinant attribute, right? So you should be looking into the set of determinant attribute. So that is important. So you cannot take any attribute from the right hand side of FD. So this is kind of thumb rule, right? So with this I'm closing. So because we have taken out all the possible discussion.